Hello, everyone, and welcome to the University of Manitoba's Resources for Agricultural Engineering webinar series. I am your host, Dr. Udwak Edets, an agricultural engineering research extension engineer in the Department of Biosystem Engineering. Our mission is to enhance the visibility of agricultural engineering profession in Manitoba, forge meaningful connections with agricultural communities, and help farmers address their engineering needs and aspiration through knowledge transfer and collaborative, rapid value creation of practical solutions in agriculture. Before we go further, if you have not completed the um, pre-webinar survey, please just take 30 minutes to do that. I have shared it on the chats, meeting chats. So if you can do that, that would be nice. So before we also go further, I want to acknowledge the traditional territory. The University of Manitoba's campuses and research spaces are located on original land of Anishinaabe, Iniwak, Assiniwak, Dakota, Oyete, Deni, and Inuit, and on the national homeland of the Red River Métis. U of M recognizes that the treaties signed on this land are a lifelong, enduring relationship, and we are dedicated to upholding their spirit and intent. We acknowledge the harms and mistakes of the past and the present. With understanding, we commit to supporting Indigenous excellence through active reconciliation, meaningful change, and creation of an environment where everyone can strive. Our collaboration with Indigenous communities is grounded in respect and reciprocity, and this guides how we move forward as an institution. Today, we have three amazing guests that we touch on different topics related to research expertise and infrastructure in biosystem engineering, funding sources, things surrounding IP, and research agreements. Before we move on, just some quick housekeeping rule. The webinar is recorded and would be posted on our website once um, it is prepared. But please try to mute your microphone during the presentation to avoid distraction. And if you have any question, please put it on the chat box. So the way the webinar would go is that all three presenters would finish presenting before we now have a live question and answer section. So with that being said, our first presenter is Professor Danny Mann. He's originally from Western Manitoba, has a strong academic background with a bachelor, master's, and PhD in biosystem engineering from the University of Manitoba. He joined the Department of Biosystem Engineering in 1998, becoming an associate prof in 2004 and a professor in 2008. He has held various administrative roles, including head of the department since 2009, and is a registered professional engineer. Professor Mann focuses on curriculum development, particularly an innovative capstone program, and his research expertise include agricultural economics, safety, and assistive technology. His current research involves integrating real-time sensory information into automation for remote supervision of agricultural machines. He has been an active member of the Canadian Society for Bioengineering since 1998, served as president, and has received multiple awards, including the Young Engineer of the Year Award and the Maple Leaf Award. He has also been recognized for his teaching excellence with several accolades and was awarded the Champion of Engineering Education Award in 2025. Let's welcome Professor Danny Mann.
Thanks, Udwak. And I will attempt to share my slides here. Do I have the right version appearing?
Yes.
All right, so welcome to this afternoon's webinar. As Udwak has introduced me, my role is to talk from the perspective of the Department of Biosystems Engineering. And we're going to look at how do we bridge the gap between industry and academia. So, the red piece in the picture on your top right hand of your screen, we're going to look at how we find ways that we can work together. As a way of introducing the department, I thought of doing it with a few fun facts that I'll give you related to our program. So our department has existed for a long time, and from 1968 until 1995, the degree that was awarded by the University of Manitoba was called an agricultural engineering degree. And since 1995, that has transitioned to being called biosystems engineering. We are, as of this point in time, this point in history, we are the only bioengineering program left in Western Canada. We make impact on two faculties. That's an interesting way of phrasing or describing the fact that we belong to our home faculty is the Faculty of Agricultural and Food Sciences. So we have strong ties to Manitoba's ag sector. But our undergraduate program is accredited through the Price Faculty of Engineering. So we have very strong ties to both of those faculties. We have a history of innovation. You'll see some of those examples of the research innovation in the slides upcoming. We also have a history of teaching innovation in areas such as bringing together communication within our capstone courses, bringing together prototyping within our capstone courses. And finally, the last fun fact, leaders. If you look to the Price Faculty of Engineering, the dean of that faculty, if you look to the CEO of Engineers Geoscientists Manitoba, you'll find that they are alumni of our biosystems engineering or agricultural engineering degree department. So, we have a history of creating these leaders. Last point to make on this slide, our undergraduate degree has three specializations, those being biomedical, bioresource, and environmental. And in all cases, they reflect areas where the engineering world intersects with biological systems. And then finally, on the right-hand side there, we have a course-based Master of Engineering degree that is also available with a co-op option. And then finally, our thesis-based Master of Science and PhD programs. So the roots of our department are agricultural engineering, and it's a unique history, a unique story. It was created by a mechanical engineer who partnered up with some of his colleagues from electrical and civil engineering, bringing together their expertise to work at solving the problem of the day, which the early 1900s was the production of food. And that led to the development of sort of different streams or specializations, which we could describe as agricultural machinery, as post-harvest technology, as agricultural structures, and as soil and water engineering. And there have been some branches off of that in terms of food processing or bioprocessing, and then looking at the environmental impacts that are associated with agriculture that have sort of grown from it. But right from day one, agricultural engineering was a collaborative effort, and that seems to still that aligns with the theme that we want to talk about today, looking at this collaboration between industry and academia. And when we look at our existing research expertise in the department, I've tried to draw the boxes in alignment with the previous slide. And you can see that there is still a very close alignment with those agricultural engineering routes. I guess the one exception, the bottom right-hand side of your screen, we do have one vacancy right now so we don't have any expertise in agricultural structures area. The one area that is new and different compared to traditional agricultural engineering is the box that's at the middle bottom of the screen, the biomaterials engineering. And that really came about, 10 to 15 years ago, an opportunity when the former Department of Textile Sciences merged with our department and brought this unique expertise into our fold. So over the next few slides, there's one slide for each professor that is in the department, and I'm going to try to restrict my comments to 1 or 2 points about each of these individuals, and they're going to appear in alphabetical order by their surnames. So starting with Dr. Warren Blunt, and Warren has his philosophy behind his research is to take a circular economy approach to looking at waste materials and trying to valorize those, turn them into something that is could be described as a renewable bioproduct. Dr. Nazem Chichik is, speaking of those leaders, I made mention of leaders before. Dr. Chichik has recently been named the Dean of the Faculty of Agricultural and Food Sciences. So his involvement in research activity at the moment is somewhat limited, but has expertise in the treatment of livestock waste and wastewater treatment, and has been instrumental in the utilization of renewable bioproducts as well. We have and I have to say this, that it's subject to presidential approval at a meeting, I believe, happening next week, but Dr. Uduak Edet is going to be joining us as an assistant professor effective July 1st of this year, and he is going to be developing a lab that he's entitled the Smart Agricultural Systems Lab, which is going to look at modeling of soil plant machine interactions using smart sensing technologies. And so we're excited about that new area coming into our department. We have one engineer who's working in the food engineering area, and that is Dr. Chingiz Erkenbayev. And if on the image that's provided on this screen here between the continuum from post-harvest to retail, Chingiz works primarily at the processing. So what happens with those commodities from the time that they're in storage when they make their way towards what we end up purchasing in the supermarket. Perhaps the area where our department has the most international recognition is in the area of grain storage, and it really is, the innovation here was looking at the granary, the storage structure as an ecosystem, and many attempts, years of attempts at modeling that from a mathematical basis. And Dr. Fuji Jian is the current individual who's really carrying that torch forward. Dr. David Levin is the one professor in our department who does not have any kind of an engineering background. His microbiology background makes him the perfect individual to lead the charge in the areas such as biological or microbial production of bioproducts and biofuels. Dr. Jiting Li is one of our newest professors and brings expertise in remote sensing and the use of drones. And her research is really focused on trying to come up with advanced models that are combining AI and physics for modeling crop and animal production systems. I mentioned the joining of the Department of Textile Sciences with our department a number of years ago. Dr. Song Liu is one of those professors that made that transfer and brings his applied chemistry type of background to to looking at surface engineering. So it's imparting beneficial characteristics to the surfaces of various entities that are used have applications in medical, in food processing types of applications. My own area, Dr. Edith already gave you a bit of an overview of my research expertise. And so I'm very much a machinery perspective or machinery person, but a systems perspective where it's not just about the machine, it's how the machine interacts, or I guess how the operator interacts with the machine. And as we see these machines going closer to it being autonomous, we realize that it's still necessary to think about ergonomics even in those types of machinery systems. Dr. Jason Morrison brings a unique background of mathematics and computer science and mechanical engineering, and his research expertise is best described as applied quantitative modeling. And that is applied in things like imaging and sensing, in CAD and additive manufacturing, and in data science. And the second individual in the grain storage area is Dr. Mohammed Nadimi, also one of our newest recruits into the department. And he's the first individual that we've hired with an electrical engineering background. And so he brings his biophotonics, imaging, and spectroscopy background and applying that towards smart grain quality monitoring. Dr. Rahman, another of the former textile science professors, has a real interest in looking at waste biomass and trying to understand, well, first of all, to extract the fiber from those waste biomass materials, and then identify what would be the most useful application for those types of fiber, whether it's going into composite manufacturing, whether it's going into traditional clothing and various other applications. Dr. Sri Ranjan is our lone engineer that has expertise in the soil and water area. So anything related to irrigation, drainage, remediation of contaminated soils and groundwater, those are the areas where he's interested. And really, to a large extent, it's about optimizing water usage in agricultural production through innovative irrigation strategies as well as innovative drainage strategies. And finally, our last professor, the third of the people from the former Department of Textile Sciences, is Dr. Wen Zong. And she has been doing a lot of work recently developing interesting biosensors using hydrogels. And again, they have different applications in healthcare and biomedical applications. So with that very quick overview of the research expertise in the department, and I hope that you've seen that, I mean, it's engineering, but it's engineering that's relevant to living systems. So I think it aligns with our definition of biosystems engineering quite well. That's obviously one of the things that we bring to the table as researchers in the department. We also bring access to graduate students, and we bring to the table knowledge of funding opportunities. And of course, what we want, the reason why we've planned this webinar today is so that we can bring our set of assets to the table and meet up with industry who we understand you bring practical problems to the table. And this is all about exploring the possibilities for collaboration. And we recognize fully that not all problems are the same. There are many options for us to collaborate. Your mind might, immediately be jumping to, well, research collaboration means, we're going to get a master's student or we're going to get a PhD student and, we're going to undertake a long, lengthy project. Those are options. Those are the last two columns in this chart. But those are not the only options. There are many there other options that we can rely on that perhaps are shorter term that could provide a more immediate study and start to answer some of those questions. They may lead into the longer term studies involving the traditional the MSc or the PhD type of projects. But as you see in this there's a lot of information in this one chart in terms of the nature of the product, sorry, the nature of the project, the type of deliverables, whether there's industry involvement, the cost to industry, and so forth. The final resource, I guess, or vehicle, maybe a better term, that wasn't reflected in that chart, it relates to this University of Manitoba Resources for Agricultural Engineering initiative. And I'm not going to spend a lot of time unpacking all of what we're trying to do, but just to highlight the fact that what we are doing essentially is trying to establish the concept of extension engineering at the University of Manitoba, which means that we have that one person, that extension engineer, who is available to be able to talk with industry and to do some of that preliminary investigation of problems that come up and try to figure out how we could best go about addressing those. And so, this is sort of our model that we look to from problems to solutions. So, as industry, you are the stakeholder. You perhaps come with a problem that you are facing. You link up with our extension engineer. That's the consultation bubble. The purpose of that is to make sure that we understand what the problem is and understand what kind of resources are going to be needed in order to try to tackle that problem. Identifying the existing resources means looking at the university environment. What is the right professor to approach? What research infrastructure do we have in the department that is relevant to the problem? Trying to pull all of those what is existing, pull it together. If there's everything aligns and there's the opportunity to work on the problem and perhaps get to the point where we can provide a solution, or maybe we get to the point where we realize that we're going to need to do some further study, and that might mean then going the route of trying to get some extra funding, getting a master's student, so forth. But this sort of is the general model that we see. And over the last couple of years, it's only been 2 years that we've had this particular model happening, but we've been able to complete a number of projects. And you see from this slide, the projects are all very different. They might be a feasibility study. We might be demonstrating some technology. We might be utilizing some of our analytical equipment to do a fee-for-service sample analysis. Maybe we're simply doing a literature review to try to understand the state of the art and decide, which is the logical direction to move into next. Or maybe we do some preliminary investigation and that leads to the development of a funding proposal for a more in-depth study. And we've got experience with all of those. So I'm going to switch gears here for my last 3 slides and sort of look at it from the perspective of the industry. So industry, you might say, but we have no funds to contribute to research collaboration. As department head, I would say that's okay, because we've just seen that we've got this UM-RAE initiative. We've got an engineer that can take on some of that short-term work. There are some funding opportunities to provide some short-term personnel costs. We can go the route of describing the project as an undergraduate thesis project to get 3 months of effort by an undergraduate student with oversight by a professor. If the project is more a design and innovation focus, then a capstone design project, a little bit longer time frame, 4 to 5 students working in a team to come up with some kind of a solution. Another option, industry might say, we have minimal funds to contribute. Are there ways to leverage our contributions? And again, the answer is yes. And my point today is not to delve into the details about MyTax or the Sustainable Canadian Ag Partnership or NSERC Alliance, just to recognize that our researchers are familiar with the details of these different research programs and are happy to have discussions and try to find the right model for the set of circumstances. And finally, industry might say it's not a question of funding. We want our personnel to upgrade their expertise. And this model, and I will not take credit for this. This is not my idea, but one of my colleagues, Dr. Sri Ranjan, has used this model quite effectively. And basically, from speaking to our industry people, you sponsor your employee during their graduate studies. So you allow them to devote some of their workday towards graduate studies. We would identify a professor with the necessary expertise who would provide that academic supervision. Your company would cover the research costs, such as materials, consumables, and so on. You would essentially solve your problem, but retain the expertise in-house. So we understand that every situation is unique. We believe we have multiple vehicles that can help facilitate that collaboration, and we are certainly more than happy to explore the best way to provide assistance. And this takes you to our department website. So thank you very much for your attention this afternoon, and I'll turn it back over to Dr. Edet.
Thank you, Dr. Mann, for the presentation. Our next presenter is Dr. Lauren Oshipok. He's the Director of Partnership, Knowledge, Mobilization, and Innovation Office at the University of Manitoba, where he plays a key role in identifying and evaluating early-stage technologies and helping launch academic innovation out of the university environment. With a PhD from the University of British Columbia, Lauren brings to the table over 25 years of experience as both an academic researcher and technology transfer specialist. An authentic communicator and project manager, his career is marked by a passion for bridging the gap between academic innovation and their practical application in our community. Let's welcome Dr. Lauren Oshipok.
Thank you very much for that introduction. I'm going to share my slides here. Let me know if you can all see that.
Yeah, and please, while he's sharing his slide, if you have any question, please use the chat box.
Let me just move this over here. Hang on a sec. I'm on the wrong side. There we go. Let me try this one more time. Sorry about this. I'm just trying to figure. Okay, there we go. Can everybody see that? Right,
Yes.
excellent. So my name is Lauren Oshbach, and I am the director here of the Partnerships, Knowledge Mobilization, and Innovation Office at the University of Manitoba. My background. We're the Partnerships, Knowledge Mobilization, and Innovation Office. We abbreviate the name of the office as PKMI. We're located within the Smart Park Innovation Center at 100 Innovation Drive. And our office consists of myself. We have 4 technology transfer managers, 2 that will work on the applied sciences, applied research side, 2 that support researchers that work within the health science and life sciences areas. We're also the office that runs the Lab to Market Prairies program here that supports entrepreneurial training for postdocs and graduate students, both in Manitoba and Saskatchewan. And I have 2 support staff that are critical to the success of this office. Um, the PKMI office was traditionally known as the Technology Transfer Office, and for a long time, our focus was really on commercialization of technologies, of moving innovations and technologies out of the university environment and into industry and into the community. So we have 4 pillars. And the 2 pillars that I want to focus on today is the second one, which is increasing the economic impact of the research that we do here at the University of Manitoba. And one of the major ways that we do that is through identifying and helping build collaborative partnerships with industry, and as well as education around partnerships and intellectual property. One of the things that I'll talk about today about building a successful industry university research collaboration is really it comes down to communication. It's ensuring that everybody that's involved in the project understands, has common expectations on what success looks like. And the university, PKMI office, we can help support that. So often when we think about research collaborations, we think about the interaction between the faculty members, the researchers, and the industry partner. But in fact, when you build a research collaboration, there's actually 3 partners. So, you may start with the initial conversation between the researcher and the industry partner. We have a potential project. How could that be structured? How could that work? But at the end of the day, when the project is starting and the project's ongoing, the trainees are going to be involved. So the trainees are also a component of a research collaboration. And there's also an interaction between those trainees and the industry partners. They're doing the research, they're creating the reports. There's going to be conversations that go back and forth between the industry partners and the trainees and the faculty members. And when you put all of these 3 things together, in the center is where you find your research collaboration. Now, research partnerships can either be industry initiated or researcher initiated. At PKMI, we're an external facing office here at the university. And we both have researchers that will reach out to us to say, hey, look, I'm really interested in finding an industry partner to be able to collaborate with on a research project. Can you help me find someone within the ecosystem, either here within Manitoba, within Canada, or sometimes even internationally, that we could build a partnership with? We also have companies that will reach out to us to say, I have a problem. I'm looking for expertise and a potential partner within the University of Manitoba, but I don't know who to talk to. Who do I reach out to first? Who would be who among the faculty are interested in doing collaborations? Because not all researchers are focused on doing external collaborations, but we're also the entry point, so we can help assist introductions in both directions. And no matter which direction that the partnerships are coming from, all research partnerships are relationship based. At the very beginning, one of the suggestions I always like to give is that before designing a project, writing a grant application or negotiating legal agreements, it's really important that all of the parties ask themselves, first of all, what do you need for this partnership to be successful for you? And also, what do the other parties need? At the end of the day, what we're really looking for is, what does a win-win look like in a research partnership? And can we all agree from the very beginning what that win-win looks like? So sometimes we have partnerships where everyone is so excited, they just say, let's just start. I know we haven't worked out the details, but let's just figure it out along the way. And it's very often that let's just start attitude or feeling is where problems can sometimes begin. The most successful research partnerships that I've seen in my 10 years here that I've been at U of M are those that start with a very clear conversation. There's asking difficult questions. Who owns intellectual property that comes out of the project? What happens if the project deliverables change, or a trainee comes off the project or goes on to the project? If there's a budget overrun, how do we manage that as a team? We want to talk about how we align academic research with the commercialization goals of industry. There's often a lot of overlap, but academic research and industry research sometimes has different focuses. It's really important for us to sit down as a group to be able to talk about what does that look like. And then finally, we want to focus on long-term relationships. If you do a 3-month research collaboration and you get to the end of that collaboration and you say, I'm so glad this is over, I never want to work with that other person or other group again, that's been a failure. What we want to be able to do is do a project, get to the end of it, feel like we've had that win-win, and say, you know what, this is great. We both felt like we've gotten what we need out of it. Let's do a bigger project. Let's do something else. How can we continue to move the needle forward? So each of the parties that are involved in these research collaborations have different priorities. And so I've listed a few of them here. They're not meant to be all-encompassing. But at first, we start with the faculty researchers. At the very basis of what we do, we're an academic research institution. So for faculty members, we often want to have the ability to be able to publish novel results, to move our research forward. We want academic publications. We want to have our students have thesis presentations, poster presentations, that sort of thing. We want to be able to publish. We also want to provide access for student training and industry experience. We all recognize that not every student that comes through our lab is going to be a faculty member. So it's really important as us as an institution to be able to look for opportunities to put our students in a position that they can gain skills for when they leave the university. Faculty is often also looking for expertise or access to specialized expertise and equipment. Industry sometimes has the ability to be able to bring in things that we don't have here at the university. We want to be able to access that. Access to real world problems and data. Dr. Mann talked about this in his presentation. We want to be able to do work that matters and work that matters to our communities. We also talked a little bit about research funding. There are a number of different research funding agencies and funding programs that rely on having an academic and an industry partner. So being able to unlock those funds in order to do these projects is really beneficial. And finally, academic independence. And so we want the ability, again, to be able to publish, to be able to present, to be able to continue to build our research programs. What is industry looking for? Again, just like the researchers, industry partners are also looking for specialized expertise that might not be available in-house to them, but is available here at the university. And that includes access to different research infrastructure and research facilities. Often industry brings in some early stage technology that requires more improvements, more refinement, really needs to be de-risked. And a lot of that early stage work can be done here within the academic environment. Again, just like researchers, the ability to be able to leverage government funding through programs like MyText and NSERC is really, really important. And then finally, the ability to be able to evaluate and potentially recruit highly skilled trainees. So being able to work with those trainees, work with those students, whether it is for a couple of months or a couple of years, often that is a pipeline for industry partners to be able to decide whether or not that PhD student, that master's student, that undergraduate student is somebody that fits with your culture, fits with your work. And there can be a pipeline from the research lab and into industry. And finally, what are the trainees looking for? Again, the trainees are looking for exposure to real world problems and applied research. Again, they're not all going to be faculty members. So we want to be able to expand our professional network. We want to be able to look and investigate into new career pathways. And as part of that, research collaborations often allow trainees to develop commercially relevant or industry relevant skills, understanding the nuances of intellectual property, timelines around projects and development, and different deliverables that are important to industry, Um, at the end of the day, a lot of research collaborations give trainees the ability to increase their employability beyond academia. And one of the things that we do see is that trainees in industry collaborations, very often they find that they can transition more smoothly into non-academic positions because they understand industry pace, expectations, and real world impact. So I'm not going to delve in too much into IP around research collaborations. To be honest, this could be a complete hour-long seminar on its own. But just to briefly touch upon it, and I'm happy to take questions at the end or to follow up with anyone after this webinar. Ownership of background IP remains with the originating party. If industry brings in an innovation or technology into a research program here on campus, they maintain ownership of that. The university makes no claim to it. We don't put our hand into the cookie jar. The IP that you as an industry partner bring to the University of Manitoba remains with you. If part of the research project is to improve upon or continue to refine your IP, those improvements to industry IP are typically assigned back to the partner. It's very rare that I've seen projects where improvements would not be assigned back. Possible, but the vast majority of the projects that I've seen, improvements to industry IP they go back to the partner. When you're starting to talk about a research project and designing that research program, it's really clear for all parties to have clear definitions of what their background and their foreground IP or the project IP might be. That reduces friction, that reduces bad feelings and misunderstandings down the road. Sometimes what I'll do is I will ask the researchers and I'll ask the industry partner to say, write down exactly what you're bringing into this collaboration. Have it written down. Let's share it. Let's talk about it, because then 6 months, 12 months, a year year or more down the road, we all acknowledge what we brought in. And so there's no disagreements on who owns what and who developed what. Sometimes there's jointly created IP that comes out of research projects. Ownership of jointly created IP is determined upfront through discussions. The IP rights for research collaborations are negotiable. There's just a lot of moving parts, and this is why I'm not going to delve into it too much on this slide today. But jointly created IP can go to the industry partner in certain circumstances. And then finally, we always try and balance the importance of the researcher's ability to publish with the industry's potential need to protect their IP. So we try and find a balance between public disclosure of the results of our research with the need to potentially hold off for a short period of time on that publication or on that poster to allow the appropriate IP protection, whether that is patent filings or copyright filing, to be put in place to protect that IP. So this is just a comment for anyone who is a researcher on the talk today. If you design a research project where the project IP is going to be assigned to the industry partner at the end of the project, it is critically important for you as a faculty member to ensure that all the trainees that are involved in that project understand that obligation to assign their IP ownership rights to the partner at the end of the project. We often will do IP agreements at the start of a project, but it's very, very important that if you have a trainee that is working on a research project and the IP is going to the industry partner at the end, that we do IP assignments in place and those trainees are aware of that obligation. We cannot force anyone to sign over any rights to their, if they're an inventor, to their intellectual property. So trainees have a right to say, I'm not comfortable with this. I don't want to be a part of this project. But if they are working on the project and there is going to be assignment to the industry partner, we need to be able to put IP agreements in place ahead of time. So finally, we come up to a research program that involves the university researcher and the company. This is just a slide to show we have the initial research collaboration. Part of that research collaboration, there's a whole series of different things that fall around both the university side and the company side in terms of publications and length of projects, confidentiality versus having your students be able to graduate and defend their theses. who we like to work with, small scale, large scale projects, and so on. So finally, I created this slide. So I like to play with AI graphics nowadays, and I've come up with this slide. I had AI create this from the presentation today, but I think it makes a really good summary slide about some of the things to think about when you're looking to develop a research program. So you want to be able to go from idea to impact, but along the way, there's a number of different things that you need to stop. There are gates where you need to have conversations, determine whether or not you have alignment, whether or not the appropriate agreements are in place, everything is executed correctly. There are a number of steps in the process, and I encourage you all to have those conversations very early on. And that's it.
Thank you, Lauren, for an insightful presentation. Our next presenter is Kerry Hayes. She's the Director Research Contract at the University of Manitoba, where she provides institutional oversight for complex research and international partnership contracts, leading negotiation and advancing governance, risk management, and contract compliance. She brings more than 2 decades of experience spanning academia, industry, and government, with prior leadership role in business development at Medicure Incorporated and the province of Manitoba, an earlier role in intellectual property management within the life science startup sector. She holds an MSc in bioscience technology and public policy. Let's welcome Kerry Hayes.
Hello. Thank you, Dr. Edith and Danny and Lauren. So I'm going to share my slides too here. It's great. Okay. Did it work? Because I can't see. Yes? Okay. Thank you, everyone. So hi, I'm Carrie. I work in the office of the Vice President of Research International. So Lauren and I are colleagues, and I am located in the kind of flagship building in the middle of the university, the administration building, the one that's in all the pictures that you see on the fourth floor. So I'm happy to be here and talking, and I probably worked with some of you already in the past. So let me just. Okay, so probably just because it's 2:48 and I want to make sure people ask questions, I think Lauren and Danny have really already discussed why it's beneficial for industry and universities to partner. So maybe I'll just I'll just skip over this slide, just go to the next one, just so we have enough time at the end. So our office deals with, so Lauren talked a lot about IP. So our office works with dealing with doing the actual formalization of the partnerships and the agreements and the research after the two parties have decided they want to work together. So generally speaking, we do two major types of agreements. So sponsored research where, an industry partner has a problem they want to solve or something they want to investigate, and they realize one of the best partners would be someone at the university. And so they sponsor the research, which, means what it says. They're going to provide the funding for the research to happen at the university, and in exchange, the researcher will have something to publish in an academic journal. Collaborative research agreement, again, very self-explanatory. Both people are maybe bringing in funds, and they're collaborating on the project together. So the PI brings in some ideas, the industry partner brings in some ideas, and they both kind of bring in funding, either in kind or some internal funds for the project. And then the last one is a fee for service. So fee for services actually don't go through my office, but I just wanted to bring them up because we do get these questions all the time. So the difference for a fee for service and each faculty member under the collective agreement and under our policies is allowed to do as much fee for service like work as they are allowed to or they're capable of with their time. And that just means someone's hiring them like a consultant or to do work. And they have basically outlined everything for the researcher to do. And there's no, I don't want to say no, but very little intellectual input that our researcher does. It's basically they're following exactly what the industry partner wanted them to do. They give all the results to the industry partner. There's no publication. We don't own anything, and we give everything back to the researcher. So we do these three types of things. And grants, so some industry partners do still give grants to the university. And the difference a grant would be is that basically you're gifting the researcher funding to do anything within, a general scope of a project to run with the project with very little limitations. So there's nothing that's signed. It's usually in the form like of a letter saying, we're giving $50,000 for Dr. Mann to do this research. We'd like to see the results, but we're not going to have a lot of input. There's not a lot of information around deliverables or timelines. It's usually, 3 years and let us know how it goes. So those are kind of the four different things. So the top two is where my office is involved. The other two are dealt with different offices, but are still options if you're interested. So there's a few others that we do. So confidentiality agreements, non-disclosure agreements. Actually, Lauren's office and my office both can manage those types of agreements. And often this is the starting point when you're first starting, as you want to talk about some confidential information. So we have standard agreements, and Lauren and our office have the same. It's a very general agreement. We can usually sign confidentiality agreements within a couple days. We're also happy to use an industry's form of agreement. We're not particular. And so these are it is a good way to start off to make sure things are protected on both ends before you're sharing ideas. And then we do data and transfer and material transfer. So at the U of M only mandates these when you're working with human participants, which I do not think would be something that would occur often, in biosystems engineering. If it's not human samples or human data, then it's up to the researcher and the industry partner to kind of decide whether what they're sharing or the information that they're sharing or the materials needs to be protected. So we leave that up to them. But these are two other agreements that we see a lot. And, we do see it quite a bit in agriculture, but it is not actually mandatory on the university unless you're dealing with human participant information. Okay, so here's a few points of where we often enter into like more in-depth discussion with industry. So institutional costs. So the university does charge 30% institutional costs on research contracts. And I think it's important to understand that at the University of Manitoba, we have a decentralized budget model. And so what that means for industry partners, I think it's important that they know that overhead does not come to central administration and sit in a fund. All the overhead on research contracts goes back to the faculty. And it's distributed, so if there's $100 in overhead, 25 of those dollars go actually back right to the researcher. The other 75 goes back to the dean of the department. So all of the overhead is going back to the faculty for their use and the researcher directly. I didn't put this on the slide, but fee for service, if you were actually to do a fee for service agreement, the overhead's even higher, it's 40%. And again, all of that money goes back to the university, and it's higher because there's no, academic benefit for a researcher to do that work. So we charge higher overhead. Laura talked about this a bit. A deal breaker is the researchers must be able to publish. We cannot have any restrictions. There's no approval can be required by the industry partner. They must be able to have complete academic freedom. That is written into the UMFA collective agreement. That's the union of our faculty, and it's in our policies. We can include, you can review the publication, you can have it, like Lauren said, you can have a period to protect your IP, you can give feedback, but the final decision of any publication of any research results has to rest with the researcher or the student or the postdoc or the university employee. I just want to talk a little bit of research security. My unit doesn't look after that, but now we do have a unit at the university where projects are now viewed through the lens of research security. So most projects They go through a check just to make sure they align with the government's track policy. And so you will see wording in all of our agreements now that talk about research security and to make sure that none of the projects fall under STRAC. And if they do, there's appropriate measures that take place. If you have questions at the end about research security, you can shoot me a message and I'll let you know who you can talk to at the university about that. And the last thing, like IP, data and ownership of data, it rests with the university, 50% to the researcher, 15% to the university. And why I mentioned the percentage is that if the industry partner wants the data from the university can agree, but the researcher has to agree too. So both parties have to agree. In order for us to give full access to the data, it's both of us. Just that's a distinction that I just want to make clear. And this is just showing the process. We draft the agreement. We talk to our legal office. We hope that, by the time the agreement is reaching us, that you already have a scope of work and a budget. That's very important. If you guys have not talked and you don't, we will just push it back to you and say this, you need to understand what you're doing and you need to have a budget before we can really help you. I know everyone asks how long it takes. For agriculture, it's, generally a couple months, depending on what time of year, depending how long the back and forth go. And then we'd sign everything through DocuSign, and that's, just our online signing platform, which seems to work and it goes very quickly. So that's just the general flow. And I think we're almost, yeah. So just to make everything run smoothly, have all the documents in order. Make sure, and Lauren talked about this, that you have the project lined out, you know what you want to do, you have everything set kind of before you come to our office, and just respond to messages when our office or the legal office messages you, and it makes things go faster. Yeah, and I think that's it. So it's 2:57. Dr. Edith, I'm sorry. Hopefully we still have a few minutes. I tried to go quickly, but I think it was just good for everyone to see my face and know our office. And I think maybe that's kind of the part of the point of having us here. So thanks, everyone.
Yeah, thank you. Thank you so much. So we've opened the floor right now for question and answer. You can use the chat box, or you can unmute your mic and ask your question. So there's one question for Professor Daniman. With respect to power machinery, which is my area when I was at U of M in agricultural engineering, is vehicle technology, specifically motive system for off-highway application and vehicle technology proof of concepts, prototyping, demonstration, and performance testing area of interest in the department. So this individual is asking if this is an interest and in the Department of Biosystem.
Yeah, and I guess I think that there's different ways to interpret that. I think that the work, for instance, there's been a lot of modeling work that was done in a professor who just recently retired, using soil bin, looking at modeling soil tool material interactions. I see that as proof of concept of prototyping and performance testing. So, perhaps not as much on terms of, what is the drawbar performance of tractors. We don't have the capability to do that type of testing, but in the ways that relate to our research, I think that we are still doing those types of measurements.
Okay, thank you. Another question, what differentiates an industry partner that is worth engaging deeply with? And the second is, what do you most want to see from the company before putting institutional credibility behind a field validation effort? think this is a question for Lauren and Kerry.
Um,
Go ahead, Lauren. I think
yeah,
we'll have the
yeah,
same answer. Yeah.
yeah. I think so. I mean, I think that you know, it's an industry partner that is responsive, that understands that it's truly a partnership. Um, you know, where I see sometimes partnerships struggle is when it starts off as a conversation about being a research partnership, but it becomes very clear very quickly on that it's more of a it would probably fit better as a fee for service, or you know, something where you know, it's not equitable. So you know, one of the things that I do like to see is that engagement, that early conversation, that understanding that you know there's often a lot of overlap on what we see as success, but also recognizing that there are differences. And so when both sides recognize what they both need out of it, that makes a huge difference. It's the difference between, like I said earlier in my presentation, doing that one collaboration and then saying I never want to work with that other party again, and versus I've done this and this is great. Let's do a bigger one. Let's do a second one. Let's continue to move the needle.
Okay, thank you. Another question for Kerry. If the agreement process takes several months, but my project needs to start, how do I get things paid?
Okay, so if you tell us that there's a timeline you have to meet, you have a student graduating, the money has to be used by March 31st, like we'll do it on time. Like so that's not really like if you have a timeline, you just need to tell us at the beginning, say like, look, this is when it has to be, I have to do it by this date. We'll do it in time. You know, we can do it in a couple weeks, but we just have to remember that, you know, we do 2,000 agreements every year. So we try and triage appropriately, but of course we would do it more quickly or as soon as you needed it to be done.
Okay, thank you. Think there's a follow-up question. Continue on my first question. For a technology project that sits across animal observation, farm operation, environmental monitoring, and decision support, would UM-RAE typically anchor that in one department, or is there a way to structure a more cross-functional collaboration from the start? If we wanted the validation efforts to have both technical and industry relevance, what mix of faculty, facilities, and external stakeholders you want around the table? I think that's a question for Dr. and Professor Daniman.
Yeah, and I think that's a an area that we have not fully explored yet, but the University of Manitoba Resources for Agricultural Engineering, at this point, it started out entirely within the Department of Biosystems Engineering. And but I mean, the reality is many of our professors do collaborate already with professors in other departments, especially in the Faculty of Agricultural and Food Sciences. And so, yes, we do try to, when we're doing that, seeking out the resources. Although the primary look is perhaps within the department, the secondary look, if that expertise doesn't reside within the department, we do try to see if it resides somewhere else within the faculty or within the university environment.
Okay. Because of time, I if you can take please 1 minute to complete the post-webinar survey, that would actually you just provide your feedback. That would be very helpful for us to build future webinars as well. Want to especially give thanks to all our guest speakers for their time and efforts in preparing this informative section. We really appreciate it. To all our attendees, thank you for your time. I know we passed 3 o'clock timeline, but thank you for still sticking around. And we hope it was worth your time. Before we end this webinar, we Also want to let you know that the webinar will be available on our websites in the coming weeks. So please feel free to visit our website, which is UM-RAE. Just search for UM-RAE on Google and it will take you to our website. And also you can follow us on Twitter or connect with us by email or phone number to follow up on any project or anything you want further clarification on. So with that being said, enjoy the rest of your day and bye for now.